Hello dear students, in this lecture we will study applications of convex and concave lenses. So in previous lecture we have already seen all about the cases which appear in position of image formed by convex lens. So 6 cases we have discussed in convex lens. Here I would like to change one thing, that when we were writing the name of foci, we could have been more specified. Means in writing F, it will be much better if we write F1 instead of F, because that will give us more clear idea about which focus we are talking about. So this is F1, so it will be 2F1, and here it will be F2, and this one will be 2F2. Why F1 and why F2? Because you know that the primary focus of convex lens appear in this side, means from here rays are coming, so this is primary focus, that's why we have called it F1. Similarly, you can change from your notebook F, replace F with F1, so here it will be F2, again here it will F1, F1, F2, 2F2, F1. Okay, you can change it to 2 1 1 2 2. And about concave lens, you can say that where its primary focus lies, it lies over here, so you can call it F1. F1 here it will be in this side, and similarly it will be 2F1, and this will again be second 2, and this is the first one. Okay, so this is a change you can do in your notebook. So in this lecture we are discussing about applications of convex lenses. So 6 cases we have studied. Now let's take each case and let me explain its application. Okay, so the first case is when object is placed at infinity. So in this situation you can take the lens over here, this is the lens. When object is placed at infinity, means rays are coming like this, and it will converge at the secondary focus. Okay, so this is all about it. So how you can see this in your daily life? You can see, like, if you take a lens, and keep that in sun rays such that all the rays coming to this lens, these rays will look like this. And when you keep any object at focus of this lens, you will see, let's suppose you have kept an object at this point. Now you will see that these rays are getting converged at its focus. You know that rays coming from sun are very hot, and when these rays will get converged at the focus point, a lot of heat will produce at this point. Okay, so if you keep a piece of paper, it will, after a few seconds or a minute, you will see that that paper will burn out. Okay, so you can write here that in application, you can write case first we are discussing when object is placed at infinity. In that application part, before that you can also write the topic application of convex lens. We are discussing convex lens. So in the first case you can write it, it can be used as, so you can write convex lens is used as burning glass. Okay, its example you can see, when object or a piece of paper is placed at focus of lens, it will burn out, or you can say it will burn due to sunlight. sunlight. Okay, so this is the application of this part. Now let us discuss case number 2. In this case, you will see when object is placed beyond 2f, means here you are aware in which position the image will form. You can also draw. We have already discussed all these things. If it is, it will be focus. This is twice the focus, and here the image will form at this point, means image will look like this. So you can take this lens, means if object is kept at a distance which is beyond 2f, so you can take the lens as used as camera lens. How camera lens? When object is not very far, means not at infinity. So in that situation, you can use this lens as camera lens. So use as camera lens when object is not very far. Okay, so this is the application in second situation where object is placed beyond 2f1. Okay, now let us discuss case number 3. Now case number 3 is when object is placed and on 2f. Exactly when object is placed on this point, what will happen in this situation? You can see, let us first draw. If this is the convex lens, it is principal axis of convex lens, it is f1 to f1. Now the situation here is when object is placed at 2f1. You are aware that the position of image in this situation will be on 2f2. Okay, so here it is the image. Now how you can use this lens? This lens, it is very interesting case. This lens is used, or it is used as terrestrial telescope for erecting the inverted image formed by objective lens. Okay, so this is basically used in terrestrial telescope. But it is a terrestrial telescope. You will study all about this in your higher classes. And objective lens is a part of terrestrial telescope. Now you can keep this in mind, like when object or the image formed by objective lens is inverted. So how you can use this situation? When image is inverted, you can place the lens in such a way that the image form is kept on 2f. Now when image is kept on this position, then the image formed by this lens will be at same distance and of same height. But one thing which is changing here is the orientation, means if it is erect here and it will be inverted. And again, if we keep a inverted image in front of convex lens at the position of 2f, then the image formed by that lens will be erect. Okay, so this is the case. Now let us discuss the fourth case when object is placed between f and 2f. You can see here that if it is a lens, we are discussing case number 4, in which object is placed between focus and twice the focus, means focus and 2f. So here it is f or f1. It would be great if you write f1 and 2f1, f2 and 2f2. Okay, now What will happen in this situation when object is kept in this position? How the image is formed, you are aware that image will form here. Okay, beyond 2f2, and it will be enlarged. What will happen if we keep object between f1 and 2f1, and it will be inverted? What will happen with the image? It will be erect and beyond 2f2. Okay, so this is the case. About this application, you can write in cinema and slide projectors. Uh, about this, you can mention or elaborate, put the actual slide, means let us understand that together. Put the actual slide in front of lens in inverted position between f1 and 2f1, means you have to keep this slide at inverted position, means not like this, it will be like this, and between f1 and 2f2. Now what will happen with the image in this situation? The image formed in this case will be erect and enlarged and beyond 2f2. So with this you can display the image of this object or slide on main screen. Okay, so this is a application you can see in your daily life. All the application you can see in your daily life. So here in this situation you can write image formed will be magnified, image will be magnified and erect. Okay, so you have to keep in mind that when you keep the object between f1 and 2f1, it must be inverted, because if you keep the object inverted, its image will be erect, and if you keep the object erect, its image will be inverted. Okay, so this is the case. Now let us discuss our case number 5. Case number 5 is when object is kept at focus, means this is the lens and object in this situation is kept at focus, primary focus we are talking. Okay, now where image will be formed? If this is secondary focus, you know very well that image in this situation will form at infinity, like this, it will go parallel. Okay, we all of this we have already discussed. Now what is the application in this case? You can see it is used in collimator. What is collimator? Collimator is a device which is used to make a beam parallel, means if a beam is going like this, means let's suppose this is a source of light. Okay, and now you need these rays in a fashion which is parallel, means like this, you need rays like this. What you will do, you will keep a lens here in such a way that the focus of this lens will exactly lie where the source is placed, means when this beam will strike to the lens, it will go parallel. Okay, so this is the case. Okay, so this is all about application in case number second. Further you can also write another example, you can take it as torch. Torch is another example which you would familiar about. In torch, what happens? Let's see. It is a source of light like this. It is a source of light. Now, it will produce beam in all the direction like this. So if you need light intensity at this point, then it will be very less, or you can, if you need intensity at this point, it will be very less. How and why? You can see here that this will go like this one will go like this. Okay, so here you can see intensity at this point A will be very less. Now what is the principle behind torch is that a lens is placed over here in such a way that the source of light is placed at focus of this lens. Means the rays coming from this lens, these rays will be diverging, as we can see. What will happen after the refraction? These rays will get parallel like this, and at the point A, the intensity of light will be very high. So it is the application. It is also used in torch. Okay, so this is the case number 5. Now let us discuss our last case, which is case number 6. In this situation, you can see here that when object is placed between focus and optical center, means like this you can draw. This is the lens, it is optical center, it is primary focus, and object is exactly placed at this position between optical center and primary focus. What will happen in this situation? You can clearly see that we have already discussed. The ray will go like this. It will pass through secondary focus and optical center. Now if we further extend, because in this direction the rays will not meet, so here you can see it will look like this. What you can notice from here is that it is the object, this is the image, both are of same nature, means in terms of it is erect and it is also erect. So if you place or you keep your eye over here like this, what you will see? You will see image of this object more large, means you can write this lens is used as reading lens. Okay, so this is the application. Let us discuss application of concave lens. So our first case in concave lens is when object is placed at infinity. So you can see this is our concave lens, and object is placed at infinity means object is very far from the lens. So here you can see how image is formed in this situation. It will form in its secondary focus. That's why we have named this point as F2. It is secondary focus. So you can here see that its application, about we can write it is used in Galilean telescope. All about Galilean telescope you will study in higher classes. Just keep in mind that when image is coming from very far, means from infinity, you can say, when object rays are coming from infinity, its image will be formed at focus. Okay, so this is the case number first. Now our second case is when object is placed anywhere on principal axis. So here you can also write this is the case. Object is placed anywhere on the principal axis. So you are well aware that how image is formed. as you have already seen, image is formed like this. Oh, okay. So here its use means anywhere it is placed, it can be used as like this. This is the image. Its application are like used in spectacles for short-sighted people means those people which are short-sighted, means they face difficulty in seeing the object which is very far from them. Means if it is the object, a short-sighted person will face difficulty to see it. Why? Because that's issue in their eye. So what we can do in rectifying this problem, since the person cannot see distant object, but he or she can clearly see the object which is very near from their eye. Means like this, it is very difficult to seen by person with short sighted. So what will happen, what we can do, we can keep a concave lens in its spectacles so that the image of that object, that distant object, will look very near from the lens. So this is how it can be used in spectacle for short-sighted people. Okay, so this was the application of convex lens and concave lens. In the next lecture we will discuss about images. Okay, thank you so much.